Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 Math Handout, problem number 5. I'll be getting my known values from the Chapter 7 Math Handout. And here is my Chapter 7 Math Handout. We're working on number 5. So I'm going to scroll down to number 5. I can tell that it is a basic right away because it doesn't have, it does have all the resistors. Now the difference between this circuit and the one that we've done in the previous videos is this one has 4 resistors and this one has 3 resistors. So you're going to need to write out your spreadsheet accordingly. And here is my spreadsheet. If you want to pause the video right now and write your spreadsheet out, I would recommend you doing that. Let me show you this first. Also, I'm using the series parallel rules, and I've clipped out the rules that apply to series. The rules that apply to parallel. I clipped out those and put them on the screen. At the bottom of the formula handout here are a bunch of other formulas for voltage, resistance, power, and current. But you'll see here that we're only using Ohm's law and the power formula. So when I get my scratch paper, the first thing I would write down at the top of my scratch paper is the power formula wheel and the Ohm's law wheel. If you write out both of those little wheels at the top of your paper and you use your finger to cover up what you're looking for, it makes life a lot easier. Alright, so I filled in all my resistance values. This is a basic DC parallel circuit, so the first thing I'm going to solve for is RT. So I'm going to go 1 over under 1 over under 510. Scroll over plus 1 over under 6.8 times 10 to the third. Scroll over, hit plus 1 over under 1.2 K ohms. Alright. Scroll over, hit plus, hit 1, hit over under. Put in the 5.1 times 10 to the third equals 318.75 ohms. So my RT is 318.75. Alright, next I'm going to find IT. IT, if I cover up the I, is equal to the V divided by the R. So I have my voltage, I have my resistance, V divided by R. So I'll go and put it in my calculator. 102, that's my V, over or divided by 318.75 equals, hit engineering, 320 milliamps. So I don't know what to do next. Looks like I'm stuck, but if you understand the rules for a parallel circuit well enough, and you definitely should because you're not going to be able to use the formula sheet on the test. So knowing that current stays the same, what I can do is go ahead and fill in all of my currents. I can go ahead and write all my current values in here. Alright, after you get that done, we can find each individual current, because current does not stay the same. Current adds up in parallel. So again, it's going to be, since I'm looking for the I, it's going to be, cover this up, cover up the I, it's going to be V divided by R. V divided by R. And so I've got my 102 already in there. I'm just going to change the bottom number to 510. $510 equals, hit engineering, 200 milliamps. Next I'll do VT divided by RT. I'll change out the lower number to 6.8 K ohms, giving me, hit engineering, giving me 15 milliamps. All right, next I'm looking for I3, so it's going to be V3 divided by R3. So I take the 102, which is already in there, and I take the bottom number and I turn him to 5.1 K. So I'm going to leave the K in there and put the 1.2 K ohms in there. I hit equals, I hit engineering, and I've got 85 milliamps. Last but not least is number 4. So it's the 102 volts already in my calculator divided by 5.1 K ohms. So I go here, I clear out the numerical value, leaving the metric prefix, or engineering, and I'm going to hit equals, hit engineering, and it tells you it's 20 milliamps. So 20 and 85 and 15 and 200 should definitely add up to be 320 milliamps. 200, I'm not going to put the milliamps in here because I know they're all milliamps. If they're all in the same metric prefix, you don't have to put the times 10 to 0 in the calculator. So I got 200 milliamps plus 15 milliamps plus 85 milliamps plus 20 milliamps equals 320. All right, so it worked. Okay, now we're going to do power. PT is equal to IT times VT, so I have 102 volts. That's my V. I'm going to multiply it times 320 because I am looking to get that completed. All right, so PT is equal to IT times VT. I have my V, I have my I, so I have times equals 32.64. Okay, next up is P2, which is equal to I2 times V2. I've got let me put the V2 in there, which is 102 volts times my 15 milliamps. It equals 1.53 watts. Next, I'm going to do P3, which is equal to I3 times V3. I've already got the V3 in there, 102. So I just change my 15 to 85. Since 85 is also a milliamp, I can just leave the engineering in the computer and change the numerical value. 8.67 watts. All right, P4 is equal to I4 times V4, so V4 is 102 volts times the I4 of 20 milliamps. I'm going to leave the milliamps in there and just get rid of the numerical value and put the 20 equals 2.04 watts. All right, now that I've done all my calculations, I see up here at the top these values, and these are the values that you will be asked for on the Canvas answer sheet Chapter 7 Math handout assignment. All right, thank you.